Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic vectors. In the previous video, we learned how to express two given points in a plane as a vector and we solved some examples. In this video, we are going to learn how to find the vertex or coordinates of the vertex of a parallelogram. Let's learn more about a parallelogram. If you have this parallelogram A, B, C, D, as we can see in this diagram, A, B, C, D, you can see that line AB is a vector, so it's indicated here with the arrow, and line DC is also a vector. AD is a vector and BC is also a vector. If this is a parallelogram, then the vector AB is equal to the vector CD and the vector AD is equal to the vector BC. This is a special property of a parallelogram. So if you have a parallelogram like this, vector AB is equal to vector BC. Then vector AD is equal to vector BC. That is what you can see here. So vector AB is equal to vector DC and vector AD is equal to vector BC. With this property, we can find the coordinates of one of the vertices. Let's pick a question and see how to do this. So a parallelogram is shown in the diagram below. So we have this parallelogram here, A, B, C, D. Okay, find the vertex of D. So you see that the vertex D has the coordinates x, y. So you have to find the vertex. What that means is that we need to find x and y. We have the vertex A to be 1, 3, the vertex B as -2, 5, vertex C is 1, 8, and the vertex D is x, y. How do we find the vertex D? We know that if this is a parallelogram, then vector AD is equal to vector BC. Someone can also say vector AB is equal to vector DC. It's the same thing. I'm using this one. So vector AD is equal to vector BC. But what do we know about vector AD? We know that vector AD is the same as position vector D minus position vector A. We've learned this in the previous video. So vector AD is equal to OD, vector OD minus vector OA, which is the same as position vector D minus position vector A. I'm sure that by this time you are conversant with this. That is why I did not write the OD and OA. So here when I write small letter D, you know what I'm talking about. When I write small letter A, you know what I'm talking about because you solved a lot of examples. Okay, so the vector AD is the same as position vector D minus position vector A. What are the components of position vector D? The components of position vector D are the coordinates of the point D. The coordinates of point D are x and y. So the components of position vector D are x, y. Minus the components of position vector A are the coordinates of point A. The coordinates of point A are 1 and 3 or 1, 3. So the components of position vector A will be 1, 3. We know that from subtraction of vectors, x minus 1 will give us x minus 1, then y minus 3 will give us y minus 3. So we have been able to find the first part here, which is AD. Let's move on to the second part, BC. Vector BC will give us position vector C or OC minus position vector B or OB. So OC is the same as position vector C or small letter C, as you can see here. Then OB is the same as position vector B or small letter b. The components of C here will be the coordinates of point C, which are 1, 8. So the components are 1 and 8 minus the components of B here will be the coordinates of B, which are -2, 5. So if you do the subtraction, you have 1 minus minus 2, which is 3. Then 8 minus 5, which is also 3. So look at something here. We have been able to find AD, and BC. We know that this vector here is equal to this vector here. What did we learn about equal vectors? We learned under equal vectors that if two vectors are equal, then the x-coordinate of the first vector is equal to the x-coordinate of the second vector. So here, x minus 1 will be equal to the x-coordinate of BC, which is 3. And the y-coordinate of the first vector, which is y minus 3, will be equal to the y-coordinate of the second vector, which is 3. We know this from equal vectors, so we can use it to find x and y. We know from equal vectors that because vector AD is equal to vector BC, then x minus 1, y minus 3 is equal to 3, 3, because this is vector AD and this is vector BC. X minus 1 is equal to 3. The x coordinate here is equal to the x coordinate here. You find x, you get 3. The same way, y minus 3 is equal to 3. So the y coordinate in AD will be the same as the y coordinate in BC, or the y coordinate of AD will be the same as the y coordinate of BC. So y minus 3 is equal to y minus 3. We make y the subject and we will get 6. So we have been able to find x, which is 4, and y, which is 6. So we say that the coordinate of point D is 4, 6. So using this the property of parallelograms, we have been able to find the coordinates of point D. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to solve another question on parallelograms. Bye bye.